Today, I'll be teaching you about randomized block experiments. This experiment design allows you to have randomization, repetition, and control, which is what most researchers look for. Randomized block experiments are commonly used in medical research to test different drugs. They are a very useful way of eliminating bias, but keeping reliability by getting rid of nuisance factors. Nuisance factors are those that could affect the measured value but are not important. By creating blocks where subjects are labeled and distributed, the nuisance factors can be held constant in each block. For example, if mixing male and female subjects has an effect on the results, then males and females will be put into separate blocks. Randomization occurs when assigning the subjects to different treatments. A randomized block experiment are usually used to test how some drug may act when compared to another drug or a placebo. By randomizing which subject gets placed in which treatment group, any other nuisance factors are minimized, like age, height, or ethnicity. The rest of the experiment just involves comparing the data. This allows you to come to conclusions on which block may benefit from the treatment more, which treatment was more effective, etc. Even in engineering, some researchers may use human subjects to test the usability of a product. So in this example, a group of engineers have created this flight simulator that can be used to train pilots without taking them in a real airplane. But does this simulator really help the pilots train better? This engineering group will use a randomized block experiment to figure this out. First, they have chosen 2 flight schools in their area to test this out. The 2 schools have been blocked separately, then 100 trainees from each school have been chosen randomly to either follow the school's standard flight training or the group's new simulator. So in this experiment, you have the repetition from having 50 trainees in each test group, randomization in choosing the trainees, and control in using each school's standard method of training. The engineering group decided to use the Federal Aviation Administration standardized pilots test to compare results. After the results have been collected, the engineering group first has to compare the results from one block and then compare the 2 blocks together. They're looking for a significant increase in the scores from their flight simulator to show that there is an advantage in using it. Normally, the average may not be the best value to compare because of any scores that may be too high or too low, which could affect the average, but we'll use it here to make the comparison easier. In the first school, the trainees that used the flight simulator scored a 90% on the pilot's test, while the trainees who followed the standard training scored an average of 83. The trainees who used the flight simulator in the second school earned a 94 on the pilot's test, and the trainees following the standard training earned a 92. So clearly the first school benefited from using this flight simulator since the score is significantly higher, but there's not much of a difference between the scores in the second school. The first school's score using the simulator is also higher than the second school's, so the engineering group has a positive result and a negative result. Now they can either decide to do more testing or find schools that are similar to the first school and sell this flight simulator to those schools.